Okay, fine. What we have seen in the last session, we have seen the introduction about cellular networks, right? We have seen a basic integration of how a cellular networks will work. What are all the components behind it? Okay, so yeah, basic contents that we have seen, how the shape of the shell will be, why the shape of the cell is hexagon, not about circle or rectangle or square. What are all the way to manage the traffic, right? Frequency reuse, usage of subarray cells. So these are all the things that we have covered in the last session. So the subsequent topic on this GSM, global system for mobile communication. Again, we are going to discuss the same thing but in a different perspective. What would be the role of, because GSM is the second generation communication technology pertaining to mobile computing system. So what is the basic procedure? What are all the protocols are involved? What is its architecture? Right. So these are all the things that we are going to see today. I found some interesting animations on this. I'll play that as well as we have some discussion on this. So before getting into global system for mobile communication, understand the introductory part using this animation.
Give me a second. Does anyone know about the process behind each and every call? Let's see in this video. Initially, it was 1G. 1G is the first generation cellular standard of called by different names like NPS, NPS, and IMPS. It was introduced in 1980s and it supports only voice services over the internet. It implements analog modulation technique to keep in use. 1G handsets were bulky with antenna on top of the laser. The calls of 1G are replaced by GSM, Global System for Mobile Communication. GSM is a second generation cellular standard and developed in 1981 by European Telecommunications to support voice and data services. It uses digital modulation with the while 2G handsets were cheaper and less in size. GSM was the first generation to introduce SIM cards. GSM had a certain specifications like uplink, downlink, transmission, etc. to carry information. Mainly it has a GMSK, digital modulation, and PPMA access systems.
So these facts are very very important that you have to remember. In problems, you need to substitute these things because pertaining to GSM, if any specific problem that they are ready to raise on standard specifications, you need to remember these facts.
GSM data speed was approximately 14.4 kilobits per second. GSM uses a different frequency bands in different regions. In India, it was 900 MHz and 1800 MHz. GSM architecture is the basic architecture in cellular network. It contains four subsystems: base station, base station subsystem, network station subsystem, operation support subsystem. Here is the representation of each subsystem in architecture. It is noted that each subsystem contains some component. Let's discuss the detail. First of all is a mobile station. It has two components: mobile equipment. It is the hardware used by a subscriber to access network, identified by IMEI number, International Mobile Equipment Identity. Second, subscriber identity module. It is a detachable marker containing IMEI number, International Mobile Subscriber Identity. It also allows user to send and receive calls.
So this is the first component, mobile station, nothing but the equipment with the SIM card. I think first generation we don't have SIM card, right? So we could be talking directly over on the fixed handsets. Okay, so that's what the first generation. The second generation, where GSM is being introduced, they have introduced the SIM card. That is the major thing. Along with the instrument, we have the SIM card.
Second subsystem is a base station subsystem. It also contains the two components: base transceiver system. It is nothing but mobile data. It sends and receives signals from mobile phones and it performs various functions like including the multiplexing, modulation, and encryption. Then base station controller. It controls group of BTSs. It allocates radio and hand over from one BTS to another.
So understand the second component, base station subsystem, right? So transceiver, transmitter plus receiver, right? That's what BTS, base transceiver station. It both perform the operation of sending and receiving signals from the mobile station. And you have something related to your 2 mark part A question for BTS. What is the functionality of BTS in GSM? So you are having four functionalities: encoding, multiplexing, encryption, and modulation. Right? I think all those terms are self-explanatory. Already we have seen in Unit 1 also about this. BSC, base station controller. So combination of this BTS and BSC. So it controls a group of BTS, allocation of radio channels, handover from one BTS to another. Yesterday we have seen an animation, right? How their handoff procedure is happening between from one cell to other cell. That has been represented in terms of station controller. So BTS plus BSC will give us the base station subsystem.
The third subsystem is a network switching subsystem, and it has five components. The main element is a mobile switching center. It is the heart of GSM. It manages mobile services like registration, authentication, etc. and performs call routing, call setup, and call switching. It communicates with other NSS components like XLR, DLR, etc. The second element is home location register. It is the central master database of subscribers in current location and information. Third one is display location register. It is a subset of HMR and holds the local database of users currently visiting location in their domain. It gives you a reach from it, then it is home network and HMR works here. When it travels to then it is visiting a both and the VNS transport here. The fourth one is equipment identity register. It is also a database that contains all valid answers on network addition IMEI number. It marks everything as an invalid answer text column. First element is authentication center. A protected database that stores copy of IMSI number for authentication and encryption purpose. It protects from a different types of frauds on network. The last subsystem is operation support as a system. It is connected to all equipment in the switching system on GSM network. It provides administration and commercial operation and manages security and operation. Performs a network configuration and maintenance task. Now let's move the GSM structure agreement. Mobile station sends a signal to DSS through an interface. The DSS routes the signal to NSS which performs various tasks as discussed earlier. DSS and NSS are separated by OSS. Finally, the signal from NSS is sent to external wired network like PSTN and ISDN. The GSM system can be simplified as follows. The user calls a certain number using the mobile SIM. The signal is received by the mobile carrier which is BTS. Then it is routed to BSC for allocating the radio channel and boosters and EC for tracking location and navigation. Finally, the signal is transferred to telephone network. At the receiver side, the signal transmission occurs in reverse direction. At the receiver side, the signal transmission.
So this could be the simplified structure of GSM, right? So these components would be involved and made it to happen. Okay, user, tower, equipment, center, telephone network. Especially BTS and BSC are combined, but in the diagram they have given separate fashion. For your understanding purpose, the architecture has been simplified in this way. Okay, so so there is a fact. Already we discussed a lot about GSM without the name GSM. Okay, here you have some facts on the screen. An important thing, the term that what they are using, sim roaming, right? Sim roaming. This sim roaming feature, the sim roaming feature has been tuned for the frequency in the second generation, but currently it's not like that. the process of BTS and BSC will take care of this. Currently, initially it was configured with the set, but now BTS and BSC will take care of this charge. That is the difference between second generation and current generation. That means a very old GSM architecture and the current architecture. As well as, I think the slide will give you the idea. People can have their own customized GSM architecture. That is also possible. By restricting their own spectrum, through that they could communicate. But nowadays in India, such type of things are restricted for defense communication. Even who will be using GSM? Now everything on satellite. Sorry. So the basic architectures are tuned with respect to the number of channels, how many users that corresponding channel will support, what is the maximum number of viable channels in a cell, right? So likewise I could be able to restrict. User restriction or path restriction can be done in the very old GSM architecture, but now I can customize that, right? I can customize that. But to achieve the efficiency, the plain old architecture, we have to achieve that. Otherwise, you can't be able to see a full-fledged communication. That's the major cause here. So, this slide is completely talking about the general idea about for a standard frequency that they have given this facts. Okay, so I'll share this slide on your leisure time. Let's go through and solve it. Specifications. See, the old architecture needs a 4-digit pin to configure that SIM. I think you people are not aware about that. Right? Nowadays, plug and play your SIM cards are ready to use. Okay, but in those days, it's not like that. That you need a pin to activate the SIM. They will activate the SIM by dialing towards the CUI. CUI. They will make call. They will activate. You have some number. After activation only, that it is ready to work for you. But now, the sets are ready to configure your cards. Once you put, by default, it is ready to done through its emergency settings. It will happen. Apart from that, if I could not able to access my SIM card, it could be used as a stationary service access point. I could be able to do emergency calls. So even those features are available nowadays. The third point, they're talking about flooding actually. Mobile sends identities of 6 candidate base stations for handoff. Six represents the size of my hexagon, right? Hexagon size. 6 sides are there, so it will flood from any one side. I will get my handoff procedure. That's all. That is the basic idea. SMS. See that initially we could be able to send 160 characters. What is the maximum number of characters that we could be able to send today? Even we have the features of integrated voice and data. I could be able to send an MMS. And we have the feature of sending one message to multiple persons, right, at a time, the same time, group messages. This could be a basic problem to understand it, right? So they have given cluster size, cell size is unique, how many users are per square kilometer, what is the band allocated, what is the bit rate, uplink and downlink, what is the code rate that they are using. they have raised some question. So how to calculate that? Already in the previous session also in the cellular network I have shown you some formulas. You can use those things, right? So they have solved the problem here. So how much bandwidth is available per cell using FDD? Right, maximum that you could run with some divisions, multiplications. That's all, not more than that. So whenever you are going to perform that, make sure that you are going to work with some standard units, SI units. So do not deviate from that. So how to compute the radius? Basic thing, area of square. That's all. Right? Cell radius. Cell is hexagon. Remember that we have seen that drawing the radius by covering 19 users, 7 users, 4 users. Right? So how to compute the cell radius? So please remember that they have given the area. So how to compute the cell area? 100 users per square kilometer. How many users that cell will support when they are going to use FDMA? How much bandwidth is available per cell using FDD? So 49 megahertz means 7 into 7. So ultimately 7 megahertz per cell will be used. So if it is 7 megahertz means that could be divided by 2 for FDD. Duplexing, right? So 3.5 megahertz for uplink and 3.5 megahertz for downlink. Ultimately, we can't expect this exact value 3.5. For mathematical purpose, it will come as 3.5, but it won't come like this. It will come 3.34 or 3.4, likewise it will come. So 35 channels are there. TDMA is employed within each channel. What is the bandwidth and data rate? Right? So you could be able to compute in terms of bits per second. They are asked about data rate or bandwidth. So time slots. 10 users means ultimately that represents that time slots will be reflecting that much number of users. So how long a user can utilize a slot? What could be the maximum frame length that could be the maximum size? How many bits a slot will get to consume? Right? So nothing but that. What could be the actual data rate that should be multiplied with a second? It's all. The time taken to process a frame. So the second generation GSM. Second generation GSM. They have mentioned, right, architecture specification, very detailed, 500 pages. You could able to download it from ITU website. The very old GSM data. So can you able to identify the data rate up to 9.6 KB per second? Now we are running with the GBs and TBs. Right? Remember about the age where we are. It's always interesting to know about the old contents. Already we have seen this in that animation, but again, these are all the components that to be remembered. Mobile station, BSC plus, sorry, BTS plus BSC. In the MSC, what are all the components we have? HLR, VLR, along with that, we have EIR and AC. So, mobile station, base station subsystem, network subsystem. These components will form this architecture. So what are the functionalities of individual one? We have seen those things through that animation. And this is something that you need to remember. How that location services. This is also explained through that animation. But what could be the thing that you need to provide with? So you are going call made to that mobile unit. So telephone network will recognize the number and inform the gateway via that MSC. So MSC can't further interrogates the user's HLR. It will check for VLR. If the routing number returned to HLR, then it will go to MSC. Call will router to the MSC where it will close. MSC will ask the VLR, identify whether this person is available, whether this subscriber is available. VLR will check for its record. So the particular mobile unit will be identified, then that will be responded. So MSC will connect that information back to telephone. That's it. So how the communication is happening? What are all the steps? That is the procedure. We have seen the overlay architecture in animation, but the actual steps are here. On communication, the major entries here are MSC. In the MSC, the subcomponents, it will first check with the HLR, then it will go for VLR. It's not available. If it is in VLR, how to communicate. If it is in HLR, how to communicate. This is the basic algorithm that they are following. GSM location services. Do you think that nowadays location services are happening like this? Nowadays location services are based on very simple tower identification. That's all, not more than that. That is the reason why with a less number of radius or less number of service domain, that corresponding location tracking services are identified very easily. Okay. So and I show you one more video in this section that would be talking about
Identity for the subscriber. The service is required by the subscriber. The national or international location of the subscriber. The localization of the subscriber in relation to various base stations or other network elements. And the mobile station used by the subscriber. There are several numerical identity syntaxes that will be introduced in the course of this chapter. The international telephone number of a mobile GSM customer is his mobile subscriber ISDN number, or MSISDN. The number is only stored in the HLR of the home network and is never infinitely transmitted on the air interface. How do you dial this number from a public switch telephone network, or PSTN? First, dial prefix to distinguish between national and international calls. For national calls, the prefix is usually 0. For international calls, it's 2 zeros and 2 or 3 digits depending on the country. In GSM networks, it's sufficient simply to enter a plus sign instead of a double zero. The second part of the MS-ISDN, the mobile country code MCC, provides the code for the relevant country. The MCC consists of 2 digits and doesn't have to be entered when making national calls. The third part of the number is the network destination code NDC, that identifies the appropriate national network operator. The mobile subscriber identification number, MSIN, forms the fourth part of the MS-ISDN. The first 2 digits of this number determine which HMR a GSM customer is stored, which is used to locate him or her. The remaining digits identify the individual subscriber with different services like speech.
the same type of things are existing in our mobile phones too, right? We are comparing with the US, but even for our country, the same type of denomination exists.
Banks and data services requiring different MSIDs. To identify the GSM subscriber in a mobile network, each subscriber has its own international mobile subscriber identity, IMSI. The IMSI is of a standard length of 15 digits and is composed of the following elements: a mobile country code MCC with 3 digits, a mobile network code MNC with 2 digits, and a mobile subscriber identification number MSIN with 10 digits. The IMSI is required for registration in a PLMN because it's defined as an individual number code with a uniform string length of digits. The
MS-ISDN by comparison has different length of digits depending on the country, and therefore cannot be considered for a simple registration procedure. Furthermore, the customer has different MS-ISDNs for every service, but only one IMSI that can uniquely identify him internationally. MS-ISDN and IMSI are stored as permanent database entries in the Home Location Register, HLR, of the customer's home network. The HLR also contains information on the services for which the customer is registered. These are static entries. In addition, a database field is reserved for the current VLR address. This entry is dynamic and is updated depending on the location area that the subscriber is. In this way, the HLR always knows the current location.
From this, you come to know a point that HLR and VLR are linked. Okay.
The subscriber, and thus enables the routine calls to the relevant MSC. The mobile station roaming number, MSRN, is a temporary number which is the routine call in case of a mobile terminated call. MSRN is generated within the serving MSC HLR, that is, where the mobile station just happens to be at that moment. In order for a called subscriber to be identifiable, the MSRN is linked to the International Mobile Subscriber Identity, IMSI. In the event of an incoming call, the MSRN is transmitted via the HLR to the Gateway MSC, GSM, to inform it where the call has finally been routed. The MSRN has the same structure as the MS-ISDN. It consists of the country code, CC, the national destination code, NDC, and the subscriber number, SN, that is different to the SN in the MS-ISDN. While the MS-ISDN only establishes the connection to the HLR, the MSRN is used to route the call to its actual destination. If a mobile subscriber, while making a call, moves from one MSC area to another that's covered by a different VLR MSC, an inter-MSC handover is required. That is, the transfer of the call from a currently serving MSC or the anchor MSC to the new MSC, the target MSC. The anchor MSC stays responsible for all call control activities, so it has to know where to route the call. To support this, the target MSC generates the handover number HON and sends it to the anchor MSC. Using this number, it can now create a connection to the target MSC. Like the roaming number, it's made up of the country code.
How the MSCs are communicating, that's the idea they are providing.
CC, the national destination code, NDC, and a subscriber number, SN, which is also different from that of the MS-ISDN. The temporary mobile subscriber identity, TIMSI, and the location identity, LNI, are required for the location update of a mobile station. The TIMSI is generated in the VLR of the relevant postal network after the first location update.
We don't know about that TMSI, right? That will be taken care of by VLR. Will be automatically generated.
And then links to the IMSI. From then on, the IMSI is no longer transmitted for data security reasons. Instead, the TIMSI is transmitted via the area interface. This is the temporary identity of the mobile radio user. It's a sign for the mobile's presence within the location area. The location area identity, LAI, is a unique number worldwide. The net sends it via the control channels of the air interface to the mobile station, so the mobile station recognizes its current position and can store it on the SIM card. The International Mobile Phone Identity, is stored on the hardware of the mobile station, and is used to relative to the relevant terminal use. In the public entity register, DRL, the same number is stored to check number compliance. This equipment check is optional in GSM, and not every network operator offers this service. The EMI contains a check code, a group code, a terminal number requiring assembly code, and a serial number of the mobile station. The cell global entity, CGI, is a number code which identifies each cell in the location area of a GSM network. The CGI consists of the mobile country code, MCC, the mobile network code, MNC, or network, the location area code, LSC, location area, and the cell entity, CI, which indicates relevant cell within this location area.
How a particular subscriber has been identified, that could be done through this RG, right? Where he was, how they identify the location of the particular current location of the particular customer, that can be done through this very easily.
Using this code, the traffic that relevant to a cell, for example, can be evaluated statistically in the Network Management Center NMC. If a mobile subscriber is a certain location, his mobile phone usually receives frequencies from different network operators. In order for his mobile phone to synchronize the frequency of its own network operator, each base station must be given an identifier. This identity is the base station identity code, BSIC. It's broadcast by every BTS and compared with the equivalent entry on the SIM card of the subscriber. Only after verification that the broadcast BSIC is identical with the entry on the SIM card can a mobile station be registered in the network. Furthermore, the BSIC has no distinction between the serving cell and those other cells that use the same frequency as the serving cell. It consists of the network color code, NCC, and the base station color code, BCC. In order for a user to be able to use a mobile station, it must be registered on the network. After the subscriber has switched on his mobile phone, he first enters the PIN that will be stored on the SIM card. This step will not access the network. The mobile station opens communication with the network after successful PIN code. Network search appears on display of the mobile station.
These are all happening nowadays for you, right? While we are using our mobile phone during 1990s, we have to follow this procedure. So go through it. It could be something funny. Without by plugging and playing your SIM card nowadays, it's a very easy job for you. But using mobile phones during those time, we have to use our engineering stuff.
To select the radio station, the mobile station measures all broadcast control checks that have been set on all frequencies from all network operators. Then, a suitable network PLMN is authorized by the subscriber is selected. In the home country, this step first is only the network of the subscriber's own network operator, then the network of a contract partner. Now, mobile can select a suitable cell from several possible cells. After successful location update, the mobile station is in idle mode. Let's have a closer look at the location update procedure. Irrespective of where a mobile subscriber happens to be, the caller is always able to contact the network. This means the mobile network will always know the subscriber's current location, so it can put through calls. By subscriber's current location, we understand in this context the appropriate location area, that is, the area controlled by a certain VLR. The VLR controls at least one location area. However, in order to define as accurately as possible the subscriber's current location, the VLR area usually consists of several logical location areas. The process that keeps the network up to date as regards its current location is called location update. The location update is carried out when a mobile customer switches to his or her mobile station, when a mobile customer changes his or her location area, and at regular intervals after a mobile customer has not moved his or her mobile station for some time. What information is exchanged between which network elements during location update?
So this could be the case that you have to remember. This is happening even nowadays, right? Location update.
mobile station sends via the DSS the appropriate serving MSC. But
So this connection establishment procedure we will discuss later. Uh, already we have discussed about these things. If you have any things to raise queries, you can post it in the chat.